Ready-made maths, YouTube mathematics training. Teaching assistant and teacher training in mental mathematics. Today is Arithme'trick, day 5, manipulate the calculation. What we're going to be doing today is putting all of the previous strategies together and looking at how we can manipulate calculations to make them easier to calculate mentally. As we mentioned at the end of yesterday, we've now learned 5 of the main strategies for mental calculation. We looked at number bonds on day 1, double and adjust on day 2, round and adjust day 3, and partitioning and counting on day 4. We're going to put all those together today and have a really good fun time today playing with numbers and manipulating the calculation. Manipulate the calculation is basically a catch-all strategy. It allows you to look at any calculation and just to do something with it to make it easier. It kind of combines the number bonds, the double and adjust, the rounding, the partitioning, and the counting on, just allowing you to change your calculation and make it easier.
Hello and welcome to day 5 of Ready-Made Maths YouTube training. Over the course of the past 4 days, we've developed 4 really important mental arithmetic strategies. On day 1, we kicked off with number bonds, looking at how we can spot a number bond and put them together to make a calculation much easier. The second day, we looked at near doubles and developed the strategy of double and adjust. For example, 25 and 27, we double 25 and add 2. Day 3, we looked at one of the most important strategies, round and adjust. Where did you see a number, for example, 19, and you've got to add 19 to any number, we add 20 and subtract 1. Saves so much time. When the numbers get bigger, 197 for example, we add 200 and subtract 3. Yesterday was probably the longest videos that we did yesterday. We looked at partitioning and counting on. 2 kind of alternate strategies and the ones that probably children are most confident in using. For example, 48 add 36, 40 add 30 is 70, 8 add 6 is 14, put them together to get 84, or 48 add 30 is 78, add the 6, gives us the total of 84. What we're going to do today is pull all those strategies together, and we're now going to go into probably what we would probably refer to as greater depth in mental calculation. The strategy we're going to look at today is manipulate the calculation. Now, we've probably been doing quite a lot of that over the course of the week anyway, without really realising it. But children who become very, very proficient at mental calculation, a lot of children in the Far East, for example, that's pretty much their only strategy. Manipulate the calculation. They don't have the others, they just look at a calculation and think, how can I make it easier? What can I do? Can I manipulate it so that overall the calculation is easier than the one I started off with? There's a few calculations there at the top and bottom of the board. Examples of the sorts of things that we've been looking at over the course of the week. I'm going to pause the video in a second and just have a quick look at them. The first 3 which are more key stage 1, and then the last 4 which are probably year 2 into year 3. If we were developing those mentally, what strategy would we use? Just pause the video now, have a quick look, we'll come back to those in a second. Something like 9 plus 6 we'd probably have used as a round and adjust. We'd make the 9 into a 10, add the 6, 16, subtract the 1, 15. 8 plus 5, probably a near double. Double 5 is 10, and 3 is 13. 15 plus 8, I'm not sure with that one, probably a count on 15, count on the 8 to get us to 23, or 15 add 5, add 3. As we move towards the bottom 4, I think the first one is a relatively obvious near double, so that's a double 35. We add the 2 back on to get 72. The next one, 26, it's got that 19. Straight away, it's a round and adjust. We add 20 to get to 46. We subtract 1 to get to 45. The next 2, pretty open-ended. I think this is where we're looking at either counting on or partitioning. 60 and 12 gets us to 72. 70 and 13 gets us, 50 and 13 gets us to 63. Alternatively, 48 add 20 is 68. And 4 is 72, 35 and 20 is 55, and 8 is 63. Alternatively, let's think of that one as a round and adjust. 35 and 30 is 65, subtract the 2 is 63. If we've been working all week on developing different strategies, we can look at a calculation now and think, what's the most appropriate strategy? Am I going to find a number bond, a near double? Am I going to round? Am I going to partition? Or am I going to count on? As I said, what we're now going to do is take examples such as these and try and see, is there an easier way to do almost any of them? As I mentioned, what we're going to be looking at today is manipulate the calculation. Manipulate the calculation isn't anything specific. It's not we have to do it a certain way. It's what would make the calculation easier. The example we're currently looking at, 9 add 6, would have been probably a round and adjust as we mentioned. But does it need to be? Have a look at the picture in front of you. What do you notice when you look at the 9? Well, hopefully straight away you'll see there's one space for an extra cake. When we look at the 6 over here, we can actually see there is a spare cake here. Let's just put that cake over there. What we've now done is we've manipulated the calculation. We've no longer got 9 plus 6, we've got an easier calculation. We've got 10 plus 5, which gives us 15. Now from the picture that was very clear, but imagine just looking at the calculation itself. 9 plus 6, let's just pass one over. Pass one from the 6 to the 9. Instead of 9 plus 6, what we now have is 10 plus 5. We've manipulated the calculation to make it easier. So 9 plus 6 does equal 10 plus 5, and both of them give a total of 15. What we're now looking at are 8 gems in one box and 5 gems in the other box. I'm going to pause this one. I'm just going to ask you, how would you manipulate this calculation? How would you make this calculation easier? First of all, when you look at it visually, and secondly, if you were just to see the calculation on its own. So how do we manipulate this calculation? I think probably the easiest way to begin with is just to look at it as it currently is. We can see a 5 here, we can see a 5 here. I can basically create that near double that we did before to create 10 plus 3 is 13, or double 5 plus 3. That's one way of doing it, but actually, thinking back to the strategy we used with the cakes, what have we got here? We've got 8 filled and we've got 2 spaces. Let me just pass 2 over here and put those 2 in there. And we've now actually manipulated the calculation a different way. Instead of having double 5 plus 3, we've now got 10 plus 3 by passing 2 over. What we actually did really, there's 2 ways we can see this. We actually made that 5 into a 2 and a 3 if we were to use the number bond strategy, or the way that I mentioned previously is we just pass them over. 8 plus 5, we'll pass 2 of them over, so that equals 10 plus 3 equals 13. So again, manipulate the calculation, and again you've simplified it straight away.
So as we've just seen, with something as simple as 15 add 9, there's the standard way of 15 in my head, count the 9 on my fingers. As soon as you see a picture though, that automatically gives you an alternative way. We can manipulate that 9 and we think, no, it's not 9, it's 5 and 4. 15 and 5 is 20, which you can visualize clearly on the screen, and the 4 makes 24. But the real power of manipulating the calculation is actually to look at the 15 and 9 and think, wait a minute, that 9 is 1 short of being 10. Well, we'll just pass 1 over then. What we've now got is a manipulated calculation, a much easier calculation than what we started off with. We began with 15 add 9, we've now got 14 add 10, which we can do very easily to get the total 24.
I've introduced some new characters now. We've got some camels, and for some reason the camels are deciding that they're going to go on a boat and they're going to sail away. We've got 15 camels in the first 2 boats, and in the second boat we've got 8 camels. Again, how could we manipulate the calculation to get the total number of camels really quickly? Rather than pausing, we'll just look at this one as it currently is. I think we're okay with the first boat, it's full. The second boat, we can see again the 2 5s. So one way we can look at the calculation is 15 plus 5 plus 3. If we wanted to, we could pass those 5 over and fill the new boat, but we can just look at it as it is. 15 add 5 is 20 and 3 is 23. Alternatively, again, let's look at this second boat over here. It's got 8. It's got 2 spaces. Let's just take 2 of these camels. Let's pass them over here. Let's bring this boat up here. And again, we can now see 2 10s and a 3. Or, keeping them as separate numbers, we've got 13 over here and we've got 10 over here. So you can see how many different ways, just by manipulating the calculation, we can play around. With a visual, it's really, really easy. But again, the more you do it, the easier it becomes with abstract calculations again. So 15 add 8, what we did, we passed 2 over. So the calculation is now 13 add 10. Or 20 add 3, depending on which way you want to look at it. Just moving on to 3 calculations now that I've written on the board. 18 plus 7, 37 plus 6, and 45 plus 8. We can manipulate the calculation in the same way that we've done with the resources earlier on. 18 plus 7, I'm going to make on my abacus. 18. There we can see the 18. But rather than just go 1, 2, 3, 4, 5, 6, 7, what we're going to do is we're going to make up the next 10. 18, add 2, add 5. So rather than seeing it as a counting on in ones, we're seeing it again. We could also imagine, there's our 18, here's a 7, there's 18, there's 7. I'm going to pass the 2 from that 7 over to the 18. And again, we end up with 25. So 2 ways to look at it with the abacus. The next calculation is 37 plus 6. So there's 37, and here's 6. Again, straight away, I can see that I need 3 to make 40. So I'm going to take those 3 and pass them over there. So I end up with 43. Alternatively, I've got my 37. I'm going to add 6. So I'm going to partition my 6 into 3 and 3. 37 add 3 is 40. And 3 is 43. It's all saving me from that counting on my fingers all the time. We don't want children counting on the fingers. We want them to look at the numbers and think, what's the quick way to do it? The final one is 45 add 8. There's my 45. There's 8. I can pretty much see the answer straight away anyway. 45 and 5 is 50. And 3 is 53. But if I want to use one of those strategies, well, what I could do, this time I could go the other way. There's my 45, there's my 8. I can see I need 2 more to make 10, so I'm going to pass those 2 over there. So rather than 45 add 8, I've now got 43. Add 10, still with the answer 53. Alternatively, here's 45. What could I do with that 45? I've got to add 8. Well, I'm not going to add 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go 45 add 5 is 50. And 3 is 53. Now, if we go back to the board, the more we do this sort of strategy, the more we develop it first with apparatus, and then we start to turn it into a mental calculation, we should hopefully, by the time children leave year 1, have moved them away from this. 9, 10, 11, 12, 13, 14, 15, or 15, 16, 17, 18, 19, 20, 21, 22, 23. We've worked on all of these mental calculation strategies, we've backed them up visually, we're now looking at 9 plus 6 and going, wait a minute, 9, add 1 is 10, add 5 is 15. Or I'll just pass 1 over and make it 10 plus 5. 8 plus 5, well that's not going to be 8 plus 9, 10, 11, it's going to be 8 plus 2 is 10, plus 3 is 13, or I'll just pass 2 over, 10 plus 3. The third calculation, 15 add 8, 15 add 5, add 3. Moving down to these ones, 35 add 37. Well again, I can just pass 3 that way. It becomes 32 add 40. 26 add 19. I'll just pass 1 over. It becomes 25 add 20. 48 add 24. I'll pass 2 this way. That becomes 50 add 22. 35 add 28. I'll pass 2 that way. That becomes 33 add 30. What we're doing is we're making every single calculation far, far easier to do in our heads. Now let's take a look at a slightly more complicated calculation. Again, still well within year 2. 26 add 19. Our previous strategy was add 20 and subtract 1. We can now manipulate the calculation. Have a quick look. What can you see straight away? Hopefully there's a little gap over here, which means that if I take this 1 and plonk it over there, we've moved from 26 add 19. We've now got 25 add 20 is 45. We've just passed 1 over. How much easier is that? Moving on to the other 2 calculations, we've got next to that one, we've now got 48 add 24. Now yesterday, we looked at this one as a partition. We also looked at this one as a count on. I'm now going to look at it as a manipulate the calculation. I've got 48, I've got 24. How can I make this calculation easier? What I'm going to do is I'm just going to take this 2 from over here. I'm going to pass the 2 over there. We've now got a new 10. I'll exchange that for a 10. And what we've now got is 50 add 22. We've just passed 2 over. We've made the calculation much easier. Now rewrite it underneath. 48 add 24. We passed 2 over. It's now 50 add 22 equals 72. It's just saved us a lot of time. Looking at the third calculation, I'd now like you to have a little look at this one. We've got 35 add 28. I'm going to pause the video in a second. Have a look. Can you find 2 ways of manipulating that calculation to make it easier? And we find two ways to do this one. I think the first way is almost staring you in the face. We've got 35 here. We make our 28, 25 and 3. We're now seeing it as 35 add 25, that's 60, and our 3 makes 63. The other way links to the strategies that we used over with the egg boxes. We're just going to pass 2 over. I don't want 28, I want to make that into another 10. So I've now got 30 over there. I'm going to exchange that for a 10. So I've now got 33 add 30. Both of those really, really effective ways of manipulating the calculation to make it easier. What we've now created are some number bond diagrams just to help with jottings. The great thing about manipulate the calculation, it doesn't fit to any specific strategy, it can be anything you want it to be. These are a little bit more specific because I've actually separated at partition one of the numbers at each time. Again, key stage 1, how do we do 9 plus 6? We do 9 plus 1 plus 5. How do we do 8 plus 5? We do 8 plus 2 plus 3. How do we do 18 plus 7? We do 18 plus 2 plus 5. That's one way that you could do each of those. But we could, as we said, just pass the 2 over. That becomes 20 add 5. That becomes 10 add 3. And that becomes 10 add 5. Have a quick look at the other examples. We'll just pause the video just for a second. How would you fill in those number bond diagrams just so you can mentally manipulate those calculations really quickly? Hopefully what you've seen is that 6 becomes 3 add 3. The 8 becomes 5 add 3. And the 24 potentially becomes 2 add 22. I think with these, this is what you actually will do. 37, 40, 43, 45, 50, 53. I think with this one you would probably just pass the 2 over to make the calculation 50 add 22. But again, that's just another way of showing it. So just keep practicing with any numbers. It really doesn't matter which ones you pick up. 2 two-digit numbers, single-digit numbers, and start to develop, manipulate the calculation. Finally, just to kind of link into yesterday's work on counting on, we can see 57 add 36. The conventional way to do that will be 57 add 30 is 87, add my 6 would be 93. But if we wanted to manipulate it, what we could actually do, as you can look at the second example, is add the 3 first of all. 57 add 3 is 60, and then we've got our remaining 33 that gets us to 93. In effect, we're splitting our 36 really. That number bond diagram idea, we're splitting 36 into 3 and 33. The point being, you can pretty much do anything you want with numbers to make calculations easier. You can make the numbers suit you so that it can be basically whatever you want. Yesterday, we looked at the strategy round and adjust. With 95 plus 78, or 456, and 197, by the time we're getting into key stage 2, we'd probably look at this then and go, wait a minute, we'll add 100 and we'll subtract 5. What we could now do, alternatively, is manipulate the calculation. We're going to pass 5 over instead. Pass 5 over, we end up with 100 plus 73. Like we filled the box earlier on. With this one, it kind of stands out even more. I could add 200 and subtract 3, and some children and a lot of adults will still prefer to do that. But instead, what we could do is manipulate the calculation. We don't want that calculation. We'd rather this was 200, so we'll just pass 3 over. 453, add 200. Again, much, much easier. We then reached this calculation. Think back to day 1, number bonds. There's no number bonds there at all. I can't see a number bond. But actually, beneath it, can I see a number bond? I've got a 45. I really wish this was 35. So let's make it 35. It's 35, add 2. I've got 28 here. I'd love this to be 72. So we'll make it 72. 72, add 2. What we can now do is make that calculation much, much easier to do in our head. 45 and 35, that's 80. So I've got the 45 and the 35. 28 and 72. 28 and 72 is 100. Brilliant. And then we've got another 2 and another 2. So we get the answer 184. We've just manipulated it and created our own number bond. Just imagine pulling any 4 numbers up, adding them together, and just think, I can't see any number bonds, so I'm just going to make my own instead. If you want to try and take a child to a little bit more greater depth to really play with calculations, I've taken that same set of 4 numbers and just used the idea of manipulating the calculation to create something a little bit more interesting. I've rewritten 45 as 25 and 20. I've rewritten 37 as 35 and 2. I've rewritten 28 as 25 and 3. And I've rewritten 74 actually as 75, subtract 1. So I can now see I've got a 5 in each of the different numbers. If I now put the 75 with that 25, that straight away gives me 100. I've then got a 35 with a 25, that gives me 60, and the 20 gives me 80. I've now got 3 and 2 is 5, subtract the 1 is 4. So again, I get 184. Completely different way of doing it, but just to challenge children to think of their own different methods. What I then want to look at, just to finish this part of the section, is to look at this calculation. 35, 38, 39 and 32. We did double and adjust the other day, where we would have done 35, add 35, add 3. Or 35, add 35, add 4. What I want to do now is just to have a look and see, can I make 35s out of those numbers? Well, let's first of all pass 3 from 38 to 32. If I pass 3 over there, that becomes 35. That also becomes 35. We have a 35 here, and we've got a 35 plus 4 here. 35, 70, doubled is 140, add 4 equals 144. So again, just playing with the numbers, manipulating the calculation, and turning something which on the surface looks quite complicated into something that actually is relatively easy. Just looking at that previous example again, I'm sure quite a few people did spot that I could have done it a different way. There is also a number bond that jumps out at you because 38 and 32 go together. That can be done as 60 and 10, or we can manipulate the calculation by passing the 2 over and making it 40 add 30. That will give us the 70. We've then got the 35 and the 39, and we're going to change that 39 into a double and adjust. It becomes 35 add 4. Again, we have it with 70, and 70 is 140, and 4 equals 144. Just another way to do the same calculation. Even with decimals, again, like we've been doing all week, we can visualise them, and then we can use it as a mental strategy. We've got 3.4. I'm using one egg box as one whole, because it's got 10 tenths in there. And then we've got basically 3 wholes and 4 tenths. We're going to add to that 2 wholes and 8 tenths. 3.4, add 2.8. Let's just manipulate that calculation really quickly. I'm going to pass them over exactly like we did before, and suddenly the calculation is much easier. It's now 3.2, add 3. 3.3 add 3.2 add 3 is 6.2. So again, that should be quite a nice easy one to do. What we've now got is 6.8 add 3.8. I'm using the Numicon 10 piece to represent the whole now, and obviously the 8 piece to represent 8 tenths. Straight away, if we've got to manipulate this calculation, we can do it kind of one of 3 ways. I could imagine passing 2 tenths over either way. So if I was to replace my 8 tenths with 6 tenths and 2 tenths, I can pass my 2 tenths over here, leave my 6 tenths there, and I've now got 7 add 3.6, gives me 10.6. I could do it the other way. I could replace my 8 tenths again with 6 tenths and 2 tenths, or 0.6 add 0.2. This time I'll pass my 0.2 over here, I'll leave my 0.6 down here. I've now got 6.6, add 4, still got 10.6. But probably my favourite strategy is one just to kind of almost an imagined strategy. I've got 6.8 here, I'm 2 tenths or 0.2 away from 7. I've got 3.8 here, I'm 2 tenths or 0.2 away from 4. Let's just imagine it's 7 add 4. 7 add 4 is 11, and then I've got my 4 tenths that are missing. So 11 subtract 0.4 is 10.6. Any of those strategies will work. And as children move into year 5 and 6, we need to encourage them to start to see decimals in the same way that they see 2-digit numbers.
There is no official way to kind of record and manipulate the calculation, because it obviously depends on what you want to do yourself when you see the numbers. But this is just a simple way of using the number bonds diagram. 16 plus 9, in effect, what we're going to do is pass one over and make it 15 plus 10, which you can see at the bottom of the screen. But we can also show it as splitting that 16 into 15 and 1. On the second one, 45 add 19, we can show it as the 45 being 44 and 1, or we can just pass that one over and it becomes 44 add 20. As we move into key stage 2, the strategy doesn't really change. The examples I'm showing you here are very much alternatives to round and adjust, but as we'll see, as we've seen throughout the session today, there's many other ways of using this strategy. 345 add 298, we pass 2 over, it becomes 343. Add 200, 4,645 add 1,996, Again, we just pass those 4 over. We end up with 4,641, add 2,000. Brilliant strategy and can be used for almost any calculation. Just a couple of examples to try yourself. A 4-digit one and a decimal one. We should be used to the strategy by now. So rather than rounding and adjusting, can we alter either of those calculations or both those calculations to make them easier using manipulate the calculator? With the first example, we can just pass 4 over and create a brand new calculation that's much easier of 4,863 plus 3,000. With the second example, we've got two options. We can pass 2 tenths from the 4.7, which will give us 6 add 4.5, or the other way around, pass 3 tenths from the 5.8 to give us 5.5 add 5. Either way, very, very easy to do and makes the calculation much simpler.
That brings us, as usual, to the ready-made maths wall, where I'm going to ask you, depending on what key stage you're working with or how much you want to challenge yourself, to choose 2 numbers and then another 2 numbers, or 3 numbers and then another 3 numbers. Randomly choose them, get somebody else to choose them for you, and then think, what's the best way to add those numbers together? I'm going to do what I did yesterday. I'm going to use the first 20 numbers on the board. I'm going to use 4 20-sided dice. Let's say that's number 1 because that's the first number, all the way down to 33, which is the 20th number. I've rolled 6, 17, that's a 16, and that's an 18. So 6, 16, 17, and 18. So I'm going to get the 6th number, which is 49. The 16th number for 8, 12, 16, which is 21. The 17th and 18th, which is 54 and 15. To be honest, I don't really think I need to do much manipulation on this one because I've already got a straightforward number bond there. That's giving me 70. What can I do with this though? What I am going to do, I can just add it together really. 50 and 10 is 60 and 4 and 5 is 9. And I've then got a double and adjust, which gets me to 139. That one didn't work out particularly well for manipulate the calculation. I'll try an alternative one. I'll roll those dice again, and I've ended up this time with the 3rd number, with the 11th number, with the 12th, and with the 17th. 3rd, 11th, 12th, and 17th. The 3rd is 27. The 11th is 63. The 12th is 108. And the 17th is 54. So, how can I manipulate the calculation there to make it easier? Well, what I'm going to do is I'm going to take advantage of the fact that to begin with, I've got a number bond that works. So I've got 80 and 10 makes 90. I've then got 108 and 54. I'm just going to pass 2 over. So I'm going to rewrite that one in a way as 110 add 52. That's going to give me 162. I've now got a 90 and 162. I'm going to pass 10 over there to make that 100 plus 152 equals 252. And that one worked out considerably better.
I'm going to finish off this week's work with quite a complicated string of numbers to add up. Yes, there might be the odd number bond in there, but there aren't very many. And unlike the other days when I specifically set out the calculations to apply to a certain strategy, what I'm going to ask you to do now is to pause the video and manipulate those numbers any way you want. Rewrite the 87 as 80 and 7, as 85 and 2, as 84 and 3, as 70 and 17, however you find it would make it easier. Do you want the 26 to be a 25 and a 1? Do you want it to be a 30 subtract 4? How do you want to manipulate them? Try and find the easiest way so that you can put the numbers together again and find the total quite easily. What I decided to do was first of all put a number bond together that made sense. So I put the 57 with the 53. That just got those 2 numbers out of the way. You can see those in red. The ones that are in blue, I looked at a 49 and 26 and thought, aha, let's manipulate the calculation. Pass 1 over, and we end up with a much easier 50 add 25. Similarly, with the 2 green ones at the end, again, I passed 1 over, made 60 add 35. The final example, I could have gone either way here. I could have gone and passed a 2 to the 68 or a 3 to the 87. I decided to go for 65 and 90 because I spotted at the 110 at the start, so I thought I'd rather have a 90 than an 85. From that point, you can see that every single answer now is a multiple of 5. I then put the 110 with the 90, that gave me 200. I added the 65 and 35 together, which gave me another 100, that's 300. That left me with 60 and 50, which is a near double, 410. Add my 25, gives me a final total of 435. So it looked difficult, but we just had a little play, and we made it much, much easier. Now, you don't have to do that every time you get a string of numbers. What we're trying to do now at greater depth is prove what you can do if you can play around with numbers.
Alternatively, if you want to go for some slightly bigger numbers, I'm going to use my hundreds, tens and ones dice. I've rolled 908, so I'll put those together so we can see that one. 908. I've rolled 731, and I've rolled 417. I'll write those up and let you have a look at them. We'll pause the video and we'll see what we can make of those numbers. So the first one is 908. It's an interesting one to manipulate. The second one is 731. And the third one is 417. So we'll pause the video there, have a look at those numbers. They look quite complex. How can we make those easier to work with? I just had a little play with those numbers. There's hundreds of ways we could manipulate this calculation. The first thing I thought was, let's just get that over 1,000. So the first thing I did was I passed 100 over there. To make that 1008, that becomes 631, and that just stays the same at 417. And I thought, I don't want 1008, I'd rather have 1010. So I then passed 2 over here. So I ended up with 1010, 631, and 415. I'd spotted that I got 1,000 here. So straight away, I've got my 1,000 over here. So I've got 1,000, I've got another 600, and I've got a 400. Put those together, that gives me 2,000. I've then got 31 and 10 is 41, and 10 is 51, and 5 is 56. 2,056. That didn't take a lot of time, and it was just by looking at the numbers and having a little play. I'm sure you came up with completely different ways of doing it. Just have a little play and try a lot of those out yourself. Thanks very much for watching the final of this week's videos. I really hope you've enjoyed the week. I've really enjoyed delivering the training this week, and I hope it's really made sense and started to make you see numbers in a different way. We have tried to look at the visuals all week, as well as developing mental arithmetic strategies and jottings. I've just left up there a little link towards what we're going to be looking at next week. Next week is much more of a games week. The videos won't be quite as long next week. They'll be more about playing games and getting used to giving children the sorts of activities that they can use in school to constantly build up that idea of mental arithmetic and a range of strategies. We've looked today at manipulate the calculation, MC. We looked at round and adjust on day 3. We looked at partitioning and counting on yesterday. We looked at double and adjust on day 2, and we looked at number bonds on day 1. I've just twiddled them round a little bit into a different order, because next week you're going to meet a character that I use in schools all the time that really helps children to remember all of those strategies. The character you're going to meet is the maths rapper, MC Rapper Coda Numbo. So I'm looking forward to introducing you to Rapper Coda Numbo next week and to playing a load of mathematical games. Please follow me on YouTube and subscribe, please, if you can. Please follow me on Twitter as well, because I'm actually sending everything out on Twitter with all the information and all the details. I will also be putting the PowerPoint presentations that I've been using into a Dropbox folder, and I'm going to be making that available via Twitter as well. So if you want to get a copy of all the materials that I've been using this week as part of PowerPoints, and also lots of additional materials that I will be putting together over the coming weeks, follow me on Twitter. You'll be able to get the details there. You'll be able to log into into Dropbox and download those materials. Really enjoyed doing these things this week, and I look forward to seeing you all again. Thank you very much.